Thank you for taking time to be here and attend our webinar. My name is Jenna Nelson, and on behalf of Blue Marble Geographics, we're excited to share the latest and most impactful enhancements in global mapper software. Also joining us today is one of our product managers, Jeff Hatzel, who will be leading today's panel discussion. Hi, Jeff. How are you doing today?
Hey, Jenna, good. Thanks for having me on. It's always nice to be here to talk about what's new in the application.
Awesome. Thank you for being here.
Here's our agenda for today. We have a lot to cover in the next hour. I'll begin with an overview of Global Mapper updates and then provide a demonstration in the software so you can see what some of these features look like and examples of how you might use them to streamline your work. The theme of our new features is really improved ease of use and visualization options, including animations and point cloud display. Let's see, that is not all. We also have our Q&A time with a few representatives from Phase One and Hexagon. So we're excited to be joined by two special guests. We have Dr. Mohsen Miri from Phase One and Bruce Chaplin from Hexagon. And we'll have a panel discussion with them where we'll talk about new features in Global Mapper for their industry-leading file formats, including the Phase One's IIQ image format and Hexagon's ECW. So this will be a great opportunity for you all to ask questions and hear directly from the experts behind these technologies. All right, so let's talk about some software feature updates and added functions here in Global Mapper. As always, we've been taking into account user feedback, but this time we're really focusing on usability, trying to streamline workflows for users, making it easier to bring in data and find the tools that you need. So first up, you'll see the expanded Digitizer toolset. And we've added some of the most used tools for creating and editing vector features, along with calculating measurements and adding attributes to the data. So no matter what type of data you use in Global Mapper, you probably work with some form of point data or line work or polygons. And now you can find a lot of the most commonly used tools in this tool set, and you don't have to hunt through the Digitizer menus to find those options. We've also added a file browser pane, and that is going to make it easier for you to look and browse for particular file formats without leaving Global Mapper. You can have that browser pane open to whatever folder you're working with and keep that right there in your workspace, ready to go and be able to bring in data. Also added an animation tool set, and this is a big update to the current animation functionality. We can now create multiple animations and export them as videos, so easy to share with other stakeholders. So that's been a popular request. And then the new file format support that we want to talk about in our panel discussion is, again, the IIQ lossless format there and the ECW/JP2 updates to be able to better support latest versions of those file formats. The one other big thing we want to talk about that's a pro feature is the enhanced Lidar and terrain filtering, and you'll see some examples of this in just a moment. This is going to let you adjust the range of elevation values that are colored by your choice of shader, instantly scale to your area of interest. With the Lidar options, you can color by any attribute present in the data or that's been calculated by Global Mapper. And so you can easily change the color ramp, scale it to some particular feature of interest, and even filter points then by those attributes. So a lot of great stuff here. Without further ado, let's get into a demonstration of these tools.
Welcome to Global Mapper 26.2. I have some unfiltered Lidar here loaded that we're going to take and process so that we can ultimately create a flood scenario animation. And through doing this, I will be taking you through all of the new features in Global Mapper 26.2. So let's get started. We're looking at some Lidar. We might want to look in our 3D viewer. This is an unfiltered point cloud. So part of what we'll need to do first is figure out a way to filter out the water points. So for the first tool that I want to point out to everyone is the file browser. So this new file browser can be accessed from the toolbar up here. And it is a dockable window. You can keep it right here, keep it open while you're working, and easily look for particular data that you need in your workspace. Or you can move it around, put it somewhere else, close it, reopen it, whatever's easiest for you. You'll find that we can import lots of different file formats. So you can find the full list right here because you can actually filter your browser by a particular format. So if you have a lot of different project data and formats all within a certain folder, you can filter to just the file type that you're looking for to make it a little easier. So for example, I'm just going to press G on my keyboard and filter down to the geotiffs so I can easily find the TIFF for this site. So I'll double click on Laverton Creek Ortho, and now I have my ortho in the workspace. I'm going to close the file browser since I won't be using it again, and just take a look at our ortho. Since we're lucky to have an ortho for the site, we can take a look and really easily see the water on the shoreline here. We're going to have to filter this point cloud to try to identify the shoreline so that we can create a terrain grid of just the ground points and then run our flood scenario. So let's go back to the point cloud. And let's look at another big tool that's been added to Global Mapper, and that is the Lidar terrain display controls. So that button right here, you may remember, has been a Lidar filter. This filter has now been expanded upon to include a lot of display options that'll make it easy to gain more information about your data. And it's not just limited to Lidar. You can also change the terrain display modes as well. So let's start though with looking at this with Lidar. You'll find all of your drop downs for particular color by modes that let you color by particular attributes. Again, this is unclassified data. You can see other things like the elevation values and any other attributes that are present or have been calculated by Global Mapper. I'm going to use color by intensity to try to look for particular intensity values that might represent water. By default, you'll see the full range of intensity values here. And you'll notice that I've chosen a particular shader from the dropdown. The default for intensity is a gradient shader, and it's kind of hard to see particular features standing out in that just gradient shader. So I like using some of these shaders such as Plasma or Inferno because they're very friendly to colorblind individuals and just making it easier to look at the data. Let's look in 3D so we can see things a little bit better there.
Now, looking at the full range of values, it's still a little hard to see the shoreline. So I'm going to filter this and actually, or not filter, but actually change the range of values with this top slider here. And as I drag this down, you'll see things get recolored because now we're going to use that color ramp over just a certain range of values. So as you see this, we're starting to see the shoreline just a little bit better. I'll bring it down some more, maybe about 30 or so. And as I really hone in on these low values, it's much more obvious where the water points are. Now, not only is this a display tool, but it's also a filter tool. So using these display options help me figure out what attributes I might filter by. And then when I'm ready to do the filtering, I'll just scroll down to the point filter section here and check the box for the attribute that I'd like to filter. So let's check intensity. And similar to how we were doing this before, we can use the Lidar right here, and we start to see fewer and fewer points as we limit what is present in the workspace view. Let's set a minimum so that we're cutting out most of the water. I'm going to say 12 and up. All right, so now with those points removed, we can definitely start to find the shoreline a lot better. There's still a lot of points out here, noisy water points that have different intensity values, but we can certainly figure out another filter to help remove this data. Let's try elevation. So I'm going to switch to color by elevation. And let's take our slider and really hone in on these low elevation values. As you look at your histogram, you can see how the spread, the distribution of these values, and you have a lot down here in this low range. And as I move that, it gets easier to see what height the bank actually is. So as I bring that down, it looks like the edge of the bank is a little bit below a meter. So I think we should be able to filter by that. So let's go down to the point filters again. And this time expanding elevation. And let's set a minimum of 0.2. As you can see now, that has cut out all of the water points. We have a nice delineated shore. Now we've also probably cut out a few other points from the mainland here because we are filtering by intensity. Notice that there could be other intensity values up here. So we're not quite done yet. But we can take this filtered data and generate a bounding polygon so we have a boundary of the land. So I've copied my filtered data to a new layer so that now I can go and create a bounds polygon. So I'm going to switch to my filtered layer. And now I get the chance to show you another improved tool in version 26.2, and that is the expanded Digitizer toolset. So the Digitizer toolset can be found up here on the toolbar. And we started to create this toolset to make it easier for users to access particular functions. And we've been adding to this by looking at what are the most commonly used Digitizer tools and bringing them in here where they're easy to access. A lot of these tools are hidden deep within the Digitizer menus, and there is a lot of different tools in here. So to make it easier for users to find the most frequently needed tools, we brought them into this toolkit and created shortcut buttons so that users can now just perform these actions with one click. So for an example, look at the advanced section here. We've recently added the create coverage area option. So I can simply select all my points and click create coverage area to quickly generate a bounding polygon for the terrain. So that will create a new layer in my control center. And I will now have a bounding polygon that I can use to crop my original point cloud so that I'm definitely cropping out all of the water points. That might take just a second to run. All right. So here's my new polygon. Got a coverage area. If I wanted to do any further editing of this, I now have access to tools for simplification or ability to resample or edit vertices right here within the Digitizer toolset. I can even select the feature and just get a quick display of feature measurements. And those can always be added as attributes. So we're hoping everyone will find these tools handy, useful, probably things that some people might not have even realized were in Global Mapper because they were hidden deep within those dialogues. So now you can find these options for calculating slope, getting statistics for Lidar, and even generating a path profile from a selected line feature. I'm going to do one more thing with my Digitizer toolkit, and that is take my polygon and crop my original point cloud. So the crop tool is right here. So with the click of a button, I can crop just the points outside of that terrain bounding polygon. So now I'm ready to classify this data and create a terrain grid for running my flood scenario. Let's close the Digitizer toolkit just to save some room on the screen. And let's look at coloring our point cloud by classification. This is an unclassified point cloud, so let's open our automatic point cloud analysis tool and get a quick ground classification. This is a fairly dense point cloud, so I'm going to set the resolution in meters instead of point spacings. And I'm going to use the grid MCC ground classification method. I can mostly use the defaults, except I've adjusted the max height delta to just the expected variance in the ground. This area is all fairly flat. I can always double check this with color by elevation. And so I'm fine with being able to set this max height delta a little bit lower at 3 meters. Let's classify this data so that once we have classified ground, we can look at creating a terrain surface from those classified points. So that classification is run pretty quickly, and we can check the results. I like to use a filter to just filter out the unclassified points. And with all of those unclassified points turned off, take a look in 3D to make sure everything looks good. I don't want to see anything sticking up in the ground points that isn't truly ground. And of course, we can change the draw mode if it's easier to see in a different color or coloring by elevation. That looks good, so I think we're ready to create a terrain grid. So very quickly, let's use our Create Elevation Grid tool. And I actually want to make sure to keep my terrain grid limited just to the coverage area. So what I'm going to do here is select that polygon And that will be the bounds of my grid. So I can set up the grid bounds to use that selected area and then create a terrain layer. I'm going to make sure to filter to just ground so that I'm creating a ground surface. And I'll create half-meter grid cells and allow Global Mapper to fill some of the gaps there in case there are some no data areas. All right, so now we have a terrain grid. We can turn off the other layers and see that. And we are ready to run our flood scenario. For this, you can use your terrain analysis option to simulate water level rise or flooding and have Global Mapper calculate the flood rise from a particular elevation or particular area feature. I've actually scripted this process so that it will run iteratively over a range of increments. And I've saved it as a favorite script here in our favorite script manager. So this script has a variable for setting the increments of rise and then runs our water level rise tool. I can run the script right here over our loaded data just by pressing play. And it will create a polygon showing estimated area that the water would reach for each of those increments. So starting at 0.1 meters will show me where the water would likely to be, and then 0.2 meters, 0.3 meters, etc. up until I've gone, I think, up until about 3 meters of water level rise, which would be a pretty bad day here at this area. I'm going to group all of these new polygons into one group just to make it easy to manage. And I'm going to add these to an animation now. I like to have the imagery just for reference over my terrain layer. And let's open the new Animate Layers tool. So you've been able to create animations in Global Mapper, but now you can create multiple animations so you can compare different scenarios or different types of data. And you can also export them to videos. So this has been a very popular request. Hey, I've made an animation. It helps me show my data. Now can I save it to a video? So very exciting that now you can take these animations out of Global Mapper and share them. So you can save these all set up. It'll be in your workspace. I'm just going to call this one Water Level Rise. And I'm going to select all my layers that I want to be included. So just my water level rise layers. Then we should be ready to go. When I click play, Global Mapper starts alternating through these different flood scenario polygons. So I can see the water level rise over the terrain. And as you can see up in the corner, we can see the exact amount right there. So you might want to pause it. You might want to use your slider bar and see a particular frame of interest. So I can see right here, about 1.7 or so is when this water really starts to come up over the road. So I can take note of that. And if you use this record button, that allows you to export this to a video. We support multiple different formats for that. And so here's an example of the video saved and that now you can share. All right, so that's most of our new features here in Global Mapper version 26.2. I do want to show one more thing, and that is our ability to load IIQ data. And I'll open up a different workspace where I have some IIQ images. All right, so when working with these IIQ images, they will be able to be imported into Global Mapper first as picture points. And so when you bring these in, you will see these individual points representing where the image was taken. And the little arrow is showing you the orientation of the camera. These images can be orthorectified in Global Mapper. And to do that, you'll probably want at least some reference imagery. So I have some satellite imagery that I added through a custom source that we are able to access through our online data portal. And then ideally, you would also have a terrain surface to help make sure that the ortho image is scaled properly. And I brought this terrain surface actually in from our online data portal as well. So to orthorectify these images, you can start by selecting one with the digitizer and looking in the right-click menu for the Load Selected as Ortho Image option. Using this option, it's a great way to get started with orthorectifying because it's a fairly automated process. You can select that image, and if you have a terrain model, use that, and Global Mapper will look at the camera metadata and make sure to bring that image in at the correct place and scale. So for an example, I've done the first image here. Let me zoom in a little bit. So for this image, we can now see the IIQ image, which is a lot crisper and cleaner than the satellite imagery. Okay. And what I want to point out is this one was done without using an elevation model. And if you do use an elevation model here in Global Mapper, you can see a little bit of difference here in how the image has been corrected. So when I look at that other one, it looks a little bit better. Now, often though, there is still one more step to make sure the data aligns really well, and that is to rectify the image to another source. So you've got your other aerial image or ortho image here, and you'll want to choose some control points to properly align the image. So we can see things are close, but not quite where we want them to be as far as everything lining up. So if you need that precision, you're going to want to right-click on the image in the control center, find the rectify option, and add control points. Now I've already saved some control points, so I'm going to load them from a file. And you can see I've selected particular pixels from our image and then found that same location in the reference image so that I can assign coordinates. And depending on the number of control points you enter, you can use different rectification methods to help achieve better results. So we can hopefully remove distortion and have our image properly aligned. So the results of this you can see in my third image and how that aligns well with the road, buildings, etc. Of the other reference image. This process can be repeated for your other images, and you can choose some tie points in the overlapping areas to make sure everything lines up well.
All right, that's about it for giving everyone an overview of the new features.
I'm going to turn it over to Jeff now to talk about some updates with the Global Mapper SDK.
Thank you, Jenna. And that was a great demo. Obviously, I work with these features through planning and development, but then, a little break and seeing them in action is always nice. The animation updates just wow me every time. It came out really well. I love seeing some of the first things that our users are doing with it. But to that end, so some of you may be familiar with our SDK, and our SDK is a way that users can leverage global mapper functionality um, outside of the app. Maybe they're building their own apps, maybe they're choosing to call certain functions or automations and things of that nature. So the SDK allows for that. Each release of the application usually comes with a paired SDK release and SDK update. Most of those updates tend to be non-UI related updates, since generally speaking, the SDK doesn't have a UI. So in this case, right, we have added new support for the IIQ format and the ECW format updates, both of which we'll be getting into in a little more detail shortly. And Bruce and Mohsen join us. A lot of the functional updates in this SDK release are 3D related. So some of that is the 3D viewer, which can be accessed via the SDK. Improvements to camera perspective and settings of that nature. Kind of falling under that 3D umbrella is working with 3D data, a variety of updates to how Lidar processing is handled on the SDK. So if you're an SDK user or have interest in the SDK, shoot our support team a message and you can explore for yourselves. We have a whole bunch of great demo workspaces and scripts and functions that people can use as examples to get started themselves. But with that, I think we'll take a little segue here now to talk about IIQ, the IIQ file format, just a little bit before we get into our panel. So today we are joined by Mohsen Miri from Phase One, and Phase One is the company that produces the IIQ formats. Before we hop into the panel, we wanted to introduce our users both to Mohsen and to the IIQ format. So Mohsen, thank you for joining us, and please feel free to take it away.
Thank you so much, and thanks for having me. And congratulations on the new release, and thanks Jenna for the great demonstration of the solutions that you are providing to the market. Yes, IIQ stands for Intelligent Image Quality. So intelligent, we call it because it's a smart format. And for that, we take care of the size, image size, and also the quality which is inside this compressed format. So the importance of IIQ for us is based on 3 points. One is the high quality in input inside the image. Let's say it's texture, it's content, it's the quality and accuracy of the pixels inside the image, and we would like to keep it as much as possible through the workflow. The second point is the data storage, which you're seeing here compared to a TIFF file. It could be up to 8 times smaller than the classical TIFF format, and even it is smaller than a classical JPEG, 80% compressed. That means you are saving a lot of storage volume in your data sharing and also streaming. And the last point is the simplicity, which is thanks to Global Mapper integration of IIQ in images from Image SDK to your SDK. That means the simplicity and productivity in the workflow can happen. That means a streamlined processing. As you have seen in the demo from Jenna, you have the image directly inside the global mapper. you can rectify it, you can generate the auto, and also reference it to other data like images or ground control points. Maybe we can go to the next slide that I can show what we are talking about, the quality and raw format. Here you can see the non-adjusted raw IIQ image, which is a single image of one of our systems. PAS 880. PAS stands for Phase One Aerial Solutions. This is a multi-head camera, and you're seeing one of the images of the large format nadir, which is 280. In this image, you see in the shadowed area, so there are some objects that we are not seeing. So let's say underexposed or under-illuminated areas. And on top of the building, you see somehow brightness. And this is over the Little Rock City in Arkansas in the US. In summer, there is always high contrast between the top of the building and lower parts. And also you can see there are some texture missing. This is a raw format. If you take the advantages of the high dynamic range and adjust these ranges, bit ranges, you can see in the next slide that transition of these features will be somehow extracted. You can see cars. In this shadow area, you can see a black car in shadow dark area can be extracted. And this is the power of the high dynamic range in Phase One imagery. That was from my side. Thank you, Jeffrey.
Yeah, thank you. And I think that's probably a good segue into our panel now. So also joining us today is Bruce Chaplin. Bruce is a Vice President of Geospatial over at Hexagon. I'm sure many of you are familiar with Hexagon, and in our world, ECW and the JP2 formats are enormous. And so we're excited to have Bruce here talk about updates to that format and anything else that goes along with that. Bruce, how are you today? Thanks for joining us.
Doing well. Thank you, Jeff. Yeah, we're pleased to be here.
Yes, we had quite a bit of good features in there. I'd love it if you could give us just a little background, dangerous assumption that all of our users know about Hexagon and ECW, and we just had the intro from Mohsen a little bit. So it'd be great to hear a little bit about things on your side.
Yeah, sure. So, the ECW file format has actually been around, probably around 30 years now. So it's been in the industry for a long time. And there's been several iterations, let's say, of the file format itself. The ECW stands for the Enhanced Compressed Wavelet, and it's basically an image compression format, right? It's a Hexagon proprietary format, but fairly well known and well used in the industry, and it offers a great balance between, I'll say, speed, flexibility, and your compression savings. We think more so than other image compression mechanisms. Little bit along the lines of what other panelists was just saying here. There's typically a couple of dimensions, right, where image compression formats are trying to optimize along. So of course, if it's a compression format, you're trying to get the file size down to as small as possible, and typically you're trying to do that while preserving image quality. But a couple of things that go along with that, obviously, is encoding speed. How quickly is it to write files, and then decoding speed, both of which sort of impact, number one, productivity, but then also your user experience for your users that are starting to consume that imagery. So ECW, as says in the name, is a wavelet-based compression format. So it allows you to get very, very high compression ratios. So we typically see compression formats come down to 5 to 6% of the original file, for example, with kind of a corresponding, I'll say, high degree of fidelity and quality in the reconstructed image. It is lossy, right? So in principle, it runs through what we call an irreversible wavelet filter. So you are losing information, but at least to the visual eye, we call it visually lossless, right? I mean, it comes out with a very high degree of quality and fidelity. Last thing maybe I'll mention is the SDK, right, that we provide to our partners to implement ECW in their products. Also supports the JPEG 2000 format. And so in contrast, the JPEG 2000 format is lossless. And so, you sort of get a choice between optimizing for storage with visually lossless results, or optimizing for quality with a lossless format. And maybe one small anecdote, Jeff, just to kind of finish out. In terms of the amount of compression that you can achieve, we had a case study, entire country flown at 50 centimeter ground sample distance, and ended up around 45,000, 46,000 image files, close to 30 terabytes of data uncompressed. And this was all consolidated down into a single ECW file, which ended up around 439 gigabytes. So from 30 terabytes down to a single file of less than 1 terabyte, about half a terabyte. So really enormous savings in terms of the file size, and that's what our users tend to enjoy about the format.
Yeah, I mean, that's phenomenal. I still need a ton of memory on my machine to load that, I bet. But so, yeah, certainly a large compression factor. Please, everyone who's listening, continue sending in questions. I'll start, grabbing some in a second here. But I wanted to ask, Mohsen, can you tell us a little bit about how you're seeing your users utilize not only the IIQ format, but also your hardware out in the field, to paint us a picture a little bit of how it fits into our geospatial type workflow?
Yes, sure. Phase One imagery has the history of 30 years being in the market, starting from the taking care of the quality and beauty of the images, and moving to the geospatial division and also geospatial market means the beauty is and the quality is not the only thing that we take care of, and also the precision and accuracy. As I mentioned, quality is already in the format. What we are taking care of in the IIQ is also metadata. That means the IIQ carries the metadata like calibration, like any information about the sensor, and also model. And you have seen in the images that was shown by Jenna, it was based on the IXM series, 150 and also a 120 global shutter cameras. The next generation, which is our new IXM 250 camera, will be delivered with the new formats of IIQ, not the new format, new version of IIQ, which we name it IIQ X, which has even 40% smaller size. So that means for geospatial market, because the topic of a digital twin, capturing more and continuous data capturing, monitoring and observation, Earth observation, means data storage is needed more and more. And this is our response to the market. Yes, we are bringing a new sensor to the market with the 250, but don't be concerned about the amount of the image size, right? And we have this concern sometimes from the drone market, that we have the cameras like P5, P3 payload, that they think, okay, the Phase One images are large images compared to the other cameras. But we say, yes, large images means capturing less images, having higher overlap, and also covering more. And IIQ is taking care of these concerns on the image size and data size and volume and so on.
Great, thank you. So I have a question I'll throw to both of you, and maybe Bruce, you can answer first, which we haven't discussed specifically prior to this. Have you all thought, or in what ways maybe have you thought about how your products either can already be used and certain types of AI and machine learning workflows? Are you preparing any at all of that for the future? We have some tools in beta that are getting ready to be released in relation to land cover classification, object detection, and things of that nature. Where do you see your formats fitting into that in the future?
Yeah, so good question. Certainly very topical, right? Just with the amount of imagery available now in the market, so more and more, not just airborne sensors, but more and more satellite imagery being available, is sort of driving the need to automate some of our processing, right? Extracting information, right? And humans, frankly, just cannot deal with the deluge of data. We also see, sort of a move to the cloud. And so, just you've got elastic storage mechanisms and the ability to have, so almost unlimited compute. And so we've seen a lot of our customers wanting to move to the cloud and conduct their processing in the cloud. So with that, volumes of data, cloud costs quite quickly accumulate. And the ECW format allows you to kind of just compress by a large factor, right, the amount of storage needed to keep your data in the cloud. There is also, I didn't mention it, but there's a notion of a cloud optimized ECW format. Really doesn't require any changes to the file format itself, but it's comparable, let's say, to cloud optimized GeoTIFF. It's just optimizing your storage so that it's efficient to access in block storage. And I think we typically see even a sort of a 40% reduction in storage relative to cloud optimized GeoTIFF. So from an imagery standpoint, that's kind of how we see it happening, right? I was meeting with a customer yesterday, actually, and they're doing time series analysis. So more and more, you've got repeat revisits and wanting to track changes over time, looking for change detection, land cover, changes, land cover, that sort of thing. And again, as you accumulate these data sets, right, it really starts to take up a lot of storage. And so we're exploring things like compressing to ECW. Depending on the processing needed, right, you've got also the option to do lossless with JPEG 2000.
Great, thanks. Mohsen, any thoughts in that regard?
Yes, actually, it's we are somehow on the waves of AI, first waves of AI. How high this would be in these days and years, we can see and observe. But we defined a strategy at Phase One, which is called pixel supersection. And we could see somehow in Jenna's presentation, when she was somehow classifying the point clouds, classifying the objects, and defining the, let's say, water bodies, and simulating, this is exactly where the journey is going, right? Having data and deciding immediately and rapidly and correctly based on the correct data. That means for us, content and quality in means robustness and reliability out from AI machines and engines, right? And this is what we take care of, as you have seen in the dynamic range. You can play automatically or sometimes manually if you're interested, but there are so many information already in the image SDK. Metadata can help you what is inside the format and what you can find during these ranges for your processing. And this is something that we define in the strategic concept that we have in the market, which is pixel supersection. Pixels is our responsibility. We take care of the images, fidelity, color fidelity, and stability of the sensors, because they are integrated in, let's say, hybrid sensors too. You will find Phase One cameras with Regal, with Teledyne, with iSpecco, with these sorts of the sensor fusions. And these images bring the content and semantic information to the data. And these are very important that they have high quality. Otherwise, the AI-based results would be somehow suspicious to believe.
Sure, absolutely. We've had quite a few customer questions come in, so I'm going to throw a couple out there so we're not neglecting all of them for my questions. A couple IIQ questions. So to start, if at all, do you see IIQ used in the agriculture industry? And if not, do you plan on making any push into that industry?
The applications is always on customer side, right? And also the, let's say, platform here, if we say in Global Mapper, you will have the IIQ as the data format, right? And what you can extract in agriculture, you can define, so to say, what type of layers, right, and bands you're going to add, right? If you're adding near-infrared images and adding to the RGB and having other sensors combined, you can definitely go to the agriculture and any type of applications, right? Forestry, single tree extraction, depending on the GST and also the bands, 4 bands, 3 bands.
Mm-hmm. Sure, absolutely. And I think that's a good point for the larger geospatial industry as a whole, right? Because we could very logically have people using these formats across industries, right? We could have people using ECW and Phase One side by side. We very often hear Global Mapper referred to as the Swiss Army knife tool, but I think that goes to a lot of components in geospatial. Another question, Bruce, I'll throw this to you first because I don't know the answer off the top of my head, but I think this can apply to both of your formats. Can either of these formats, or have they already been adapted to be used as textures for 3D mesh creation?
I'm thinking.
Maybe I can answer it. So there are on the IIQ side. Sorry, Bruce. On the IIQ, I can say yes, and not directly to be as a format, and that it as a textual format. We can also say we can ask the question. It is also asked from the market if we can have IIQ as autophoto, right? Results and convert it. No, the texture format, we keep it right now on the outputs of the third party. Let's say what a global mapper can deliver as output. Currently, it is not on our roadmap to bring it. The reason for that is in IIQ, we say the image quality and high dynamic range and anything will be kept in the compressed format, right? If you bring these values in the whole production chain, you will transform these pixels to other type of pixels, and you will not have the high dynamic range that you have it from the beginning at the end, right? If you can keep it in the future, we can discuss it, but I don't see that in the market that IIQ could be used as a texture format on the geometry.
Right, and I think maybe a better way to think about that is the imagery could be used for reconstruction, but your output is not going to retain the IIQ or the ECW, right? It's really common for us to see JP2s come in for reconstruction and photogrammetry, but that output doesn't necessarily retain that format.
Mm-hmm.
I do want. Sorry, Bruce, go ahead.
I was going to give you a bit of a hand wavy answer, Jeff.
Okay, sure. Yeah, that's fine.
I'm not a texture expert, but the ECW format itself is very, very versatile. So since it's been around some time, right? We're now in sort of the third, again, around 30 years. We're now in ECW version 3, and the version 3 format added support for a lot of new things, right? 16-bit unsigned. Null block support, opacity band support, data statistics, things like that. So, if it's I'll say standard imagery, standard image formats, right? I would still say it's applicable. And while most of our footprint is in is in, I'll say, the geospatial industry. We have some, I'll say, alternate uses, right? Large format microscopy, for example, medical images, for example. So we have a number of other sort of image types that still compress very efficiently. It's just sort of never been a focus of ours to kind of grow into those markets. So it's worth an investigation, but I would hazard that it would be quite applicable.
Great, thank you. Let's see. I'm sure I've missed a couple other questions here. Let's see. We've had a couple questions coming from CAD users, and I'm sure you guys hear this too. Maybe we'll take this as our last question. I know we're on the end of time. Can you speak at all, Bruce? I'll just go with you since you're unmuted first. CAD, ECW, JP2000. What's the relationship like there? And then Mohsen, I'll give.
Say, what was the last part, Jeff? CAD and?
ECW, JP2000. What's the relationship there in terms of CAD support?
So we actually have a lot of CAD users using the format. For the most part, many cases it's planimetric mapping or feature collection, and they're looking for, I'll say, sort of a base map to collect off of. And so we see those in a couple of different ways. One is having local imagery and just loading imagery into the CAD platform. So we've got, major CAD providers are supporting ECW as a format. There's also cases where they will connect to a web service. And actually, another thing we haven't spoken about much, but the ECW format is quite streamable. There's a protocol we call ECWP. And so we've got a number of CAD vendors actually will connect and stream ECWP files into their application. So that sort of negates the need, right, to pull all the imagery local and that sort of thing. So we see it a good bit, both in GIS and CAD environments, just for base map.
Sure, makes sense. Mohsen, how about the IIQ format in the CAD space?
I think, let's say, it is already integrated in Global Mapper. These two different worlds, one is images and raster, and CAD is the vector. So these are two different worlds. What I can say, for example, if you have the rectified image, right, and you have, let's say, a feature abstraction tool, or you can do it manually on the screen or stereoscopic analysis, you can extract good CAD results, right? Because we are talking about extracting information from 2D raster data. And that covers both 2D and 3D. If you have oblique imagery and you have IIQ in oblique data sets that Global Mapper can support, you can have a reliable CAD data extracting from them.
Sure, absolutely. That makes sense in terms, at least how I would think of a workflow kind of moving through the pipeline. So we are at time now. That went much quicker than I thought, and I have a lot of other questions written down. So thank you both for the discussion. It was great to have you. We will certainly send any follow-up questions your way. There are some we didn't get to that if I or my team can't answer, we'll send your way to get some feedback on for our users.
At the same time that we launched this latest version of Global Mapper, we have also launched a new self-guided course, and the topic is Fundamentals of Point Cloud Processing. We do still offer some live training, but in case your schedule doesn't align with our live classes or you like to move at your own pace, definitely check out this course on our online classroom and learn more about point cloud processing, basically from start to creating terrain surfaces. All right, and a few other things. There are other videos on our website. Please consider following us on social media as well, and check out our GeoTalks podcast. Thank you all for attending, and again, we hope you stay in touch and that you are enjoying using Global Mapper. All right, have a great rest of your day, everyone.
Thanks again. Bye, Bruce. Bye, Mohsen.
Thank you very much.
Take care.